Hello. So in this example, we're just going to actually do out sort of a quick example of sigma notation so that you've sort of seen one done out sort of thoroughly and see what it does. So we have here, right, our sigma notation. So this is saying that n is our index variable, right, starting from 0 going to 5, and our sort of expression here, formula, is n squared over x plus 1. So remember, the index variable, in this case n, is the only thing that actually changes from the sigma, right? The sigma is the thing that iterates the index variable, but all the other pieces, like variables and things, namely the x in our example, is just going to stay x. It's not going to get filled in. It's just going to sort of be there, okay? So we start with our sigma notation. So we have the sum from n equals 0 to 5. And we have this n squared over x plus 1. And what this tells me is that I want to start where n is 0, plug in everywhere. So this equals, this is a way of writing the following. So I'm going to plug in 0 for all of the n. So there's only the one up top. So I have 0 squared over, everything else stays the same, x plus 1, right? Then I'm going to add, right, once I've done all of the substituting, then I iterate, meaning I increase n by 1. So at this step, right, so here, n is 0. For this next step, I'm going to increase n by 1, so now n is 1. So I plug that in, so I get 1 squared over x plus 1. Right, so that's what this term is. And again, I've plugged in everything. So now I'm going to basically do the same thing, increase n by 1. So n went from 1, now it's going to go to 2. So I'll plug in 2 for all of the n's, which is just the 1. So this is when n is 2. And so on. So then n being 3. These are new markers, so they might squeak a little, sorry. So x plus 1, so this is n equals 3, and increase by 1 again, so 4 over, this is 4 squared, sorry. This is n equals to 4. And finally, n being 5. 5 squared over x plus 1, n is 5. Now, n started at 0, it goes to 5, so I have 0 and 5, right? Remember, they both get put in. But now that I've reached 5, I'm done. So this is the full expression, right? Now I can put these things together, right? I could simplify. And in fact, that would be sort of the smart thing to do. So I'll show that. But strictly speaking, this is the extent of the sigma notation, right? So if I want to put this together, well, I'm going to compute all of these things. So 0 over x plus 1, this thing is just 0, right? Then I have 1 squared is 1. Over x plus 1. Then 2 squared is 4 over x plus 1. 3 squared is 9 over x plus 1. 4 squared is 16 over x plus 1. And 5 squared is 25 over x plus 1. Now the good news is that all of these things have the same denominator, so putting this together is actually straightforward because I can just sort of add the tops across because they already have a common denominator, right? So if I do that, it's 25 is 50 is 55. So this is going to be 55 over x plus 1, okay? So again, just as a quick recap, sigma notation, right? I just plug in the n value for the n's only. Any other letters, like other variables, stay what they are. So the x just stayed x the whole way through, right? I never plugged it in. But the top, right, I plugged in 0, and then I wrote everything down. Then plus and increased n by 1, wrote in that piece, right, plus increased n by 1, that piece, etc., and go all the way from my starting value to my ending value, including both. And so you'll notice I have, right, I went from 0 to 5. You might think that's 5 minus 0 is 5 terms, but I actually have 1, 2, 3, 4, 5, 6, right? So we have that inclusive counting, which is can throw you a little off kilter when we're going to be talking about like numbers of rectangles and stuff later on. So just keep in the back of your head that, the number of things you're adding up is maybe one higher than it might initially look like until you get sort of used to it. Okay, so that's that.